Okay, one sample t-test. As I told you, always we apply 5 steps. So step number 1, we state the null hypothesis and alternative 1. But we had only one population, one sample. So we focus on the mu, the unknown population mean. So at the beginning, initially, we set up a value. Then we had 3 kinds of alternative hypotheses, depends on the claim, the question. Then now we take the test statistic, which was the t-score, plug the point estimate, x bar, sample mean, and we take the difference with the initial setting value, because we have to compare them to make the decision later. Then divided by the standard error, which was the sample standard deviation over the square root of n, and then take the p-value from the t-distribution, decision, and finally we can interpret, it is the conclusion. Good, right? And the test statistic, the t-score, was from the z, which has the same numerator, but denominator we assumed we knew the sigma. The sigma was unknown population standard deviation, but the z was from the sampling distribution, of the x bar, which was the normal distribution, the mean, and the standard error. It's like this one. Can you remember? It's one by one, right? So based on the sampling distribution, the normal distribution, we standardize the statistic. Is a z-score. It's another test statistic when we assume we knew the sigma. And practically, we estimated the unknown sigma using the sample standard deviation. So now we have a t-distribution with a degree of freedom n-1, because the sample standard deviation was defined as square root of, take the difference, square, summation, divided by n-1. Because the n-1, it was the degree of freedom. So 5 steps we applied is one sample, it's a t-test.